In this video, I'm going to introduce some functions that you may have never heard of before, and these are called the hyperbolic functions, or also known as the hyperbolic trig functions. They have kind of weird definitions here. At least they're weird at first. Usually in Calculus 2, I kind of explain where they come from. It's a little more advanced than Calculus 1 here, but regardless, the definitions for sine hx, and you can call it sine h or you can call it sinh. I know there's no c there, but they call it that. And it's e to the x minus e to the negative x all over 2. Similarly, cosine h or cosh x is the same thing but with a plus sign, e to the x plus e to the negative x over 2. Then we have tangent hx or tanh, if you want to call it that, I guess, is sine h over cosine h. Then we have the other ones, secant, cosecant, and cotangent h, are all just the reciprocals here. So they have a lot of similarities to trig functions, as you can see the relationships between them, but where they really tie into trig functions is, as I said, something a little bit more complicated here. Now there are lots and lots of hyperbolic trig identities out there, just like there are lots and lots of regular trig identities. Most of the time, we really don't need to know them, so it's fine. There is one I think maybe you should try to know, just because it's the most common one. Similar to how to regular trig identities, you should know at the very minimum sine squared plus cosine squared is 1. The hyperbolic version of that is cosine squared minus sine squared is 1. So you see the hyperbolic ones are kind of always off by like a minus sign on a lot of the trig identities. Anyways, we will sometimes need to take derivatives of these. Now, you can take derivatives using their definitions up here, or you can memorize the results down here. Memorizing the results is probably not too bad because almost all the rules are the same as your regular trig derivatives, which you should already have memorized, except there's a couple of minus signs missing. So for example, the derivative of sine h is cosine h. The derivative of cosine h is sine h, so there's our first difference there. If it was a regular trig, the derivative of regular cosine is negative sine, but the derivative of hyperbolic cosine is positive sine. Then the derivative of tangent is secant squared h's. Derivative of secant is negative secant tangent. There's where the minus sign went. Normally secant goes to secant tangent. Here it goes to negative secant tangent. Cosecant is negative cosecant cotangent. And cotangent is negative cosecant squared. So that's not so bad. And we really aren't going to use these functions that often, but they are going to pop up now and then here. Occasionally, we are also going to need the derivatives of the inverse hyperbolic functions. And again, you can use our process for finding derivatives of inverses to work these out, or you can kind of memorize them. I would generally memorize these here. And so the derivative of the inverse sine h is 1 over square root of x, 1 plus x squared. The derivative of cosine h inverse is 1 over the square root of x squared minus 1. And the derivative of tangent h is 1 over 1 minus x squared. So again, these are similar. For example, the derivative of regular inverse sine, it's 1 over the square root of 1 minus x squared. The derivative of regular inverse tangent is 1 over 1 plus x squared. So again, a lot of these hyperbolic ones are just kind of off by a minus sign. Regardless, this is just a brief overview of these. You can play around with them a little bit on your own. And again, it's not like we're going to see them that often, but you don't want to see it on an exam and have no idea what's going on here. And so here's your video.